Welcome to Mathematics Revision Form 4, a quiz of 4 questions. Question 1. Question 1, we are told to draw the graph of the function y is equals to 10 plus 3x minus x squared. In this case, we are supposed to form a table for the range -2 less than equals to less than or equals to 5, that is starting from -2 to +5. We start by filling in the table for the values of x and values of y. So when x is equals to -2, what is the value of y? We substitute in the function 10 plus 3 into -2 minus x squared, -2. This one gives us 10 minus 6 minus 4, which gives us 0. And we do the same for all the values of x that we are given. For x is equals to -2, +1, +2, +3, and then 5. So the corresponding value of y for every value of x are given here because I've calculated for the same. Then we want to draw a graph for the function when x is equals to -2, the value of y is 0, -1, the value of y is 6, when 0, the value of y is 10, when x is 1, the value of y is 12, when x is 2, the value of y is 12, when x is 3, y is 10, when x is 4, y is 6, when x is 5, y is 0. Then we draw a very smooth curve, though we are not supposed to reinforce. I'm reinforcing because already I had drawn. When the two values of y are the same, we focus on the smallest box above, so we make it curve. Don't just draw maybe this, then you draw a straight line. Do not be a curve for that matter. Then now our next equation after drawing is use the trapezoidal rule with 5 strips. Find the area under the curve from x is equals to -1 to x is equals to 4. So in the graph, we are supposed to identify -1 and 4 as the range in which we are finding the area. So we locate the area we are finding. So this is the area that we want to determine. And then we want to find the area using trapezium method. So one, we state the trapezium method. Trapezium method says area is equals to a half h, then this bracket into y0 plus y n, first and last value of y, then 2 into y1 plus y2 plus y3 plus yn minus 1. Then we close brackets. So we need the value of h. How do you find h? H is always equals to the maximum value of x4 minus the minimum value of 1, value of x, which is -1. So then you divide by the number of strips. We are told there are 5, and this one gives us equals to 5/5, which is 1. Then we form a table. Let's get back to our table. From our table, the values of we are starting from x is equals to -1, and in this case when x is equals to -1, then we keep on adding the interval +1. So -1 plus 1 0, plus 1 1, plus 1 2, plus 1 3, plus 1 4, and we stop at 4. So the corresponding value of y, so this is our y0, our y1, y2, y3, y4, and the y5. So it's like the table was already worked out. Then we get back and substitute in the formula. So area will be equals to a half times h, our h is 1, into y0, our y0 is 6, and the y5, the last one is 6, then plus 2 into the sum of others, 10 plus 12 plus 12 plus 10, then close bracket. Here we get 0.5 into 12 plus, this is 24 plus 20, 44 times 2, 88. So we have 100 times 0.5, which gives us 50 square units. That is part A. So the area by approximation using trapezium method is 50 square units. Now what about B? B, we are told to find the exact area under a curve for the given units. The exact area is given by integration. So we are want to area will be equals to, we want to integrate from -1 to 4 the function 10x, then 10 plus 3x minus x squared with respect to x. This one gives us 10x on integrating plus 3x squared over 2 minus x cubed over 3 from -1 to 4. So we substitute a 4. We have 10 into 4 plus 3 over 2 into 4 squared minus 4 cubed over 3 minus the substitute of -1. Also we substitute -1, and this one will be 10 into -1 plus 3 over 2 into -1 squared minus 1 cubed over 3, and -1 cubed over 3. Substitute. This one gives us 42, and 42 gives us 42 and 2 over 3 minus 8 1 over 6, and this one becomes 42 2 over 3 plus 8 1 over 6, and we get 50 and 5/6 square units. So this is the area, exact area by integration. After getting the area by integration, we are asked to find the percentage error. So in percentage error, we find the error first, which will be the magnitude, the difference between the two, which gives us 5/6. Then we divide by actual, which is 55/6. Then 55/6 to mix it in proper fraction is 305/6, and we reciprocate, multiply, we get 5/6 times 6/3/5 times 100. So this one gives us 1.639%. Okay, that's our question 1 for midterm quiz. Question 2. Question 2 is a question on three-dimensional geometry. UVWXY is a right pyramid on a horizontal square base of side 10 centimeters. So the base is 10 centimeters. Calculate the height of the pyramid. So we want the perpendicular height of the pyramid. To find the height of the pyramid, we need to locate the height. After seeing the height, we have a look at what we have. So we need the diagonal. And for the diagonal, we calculate the length, which will be equals to 10 squared plus 10 squared, 10 squared plus 10 squared, which gives us the square root of 214.14. Now with 14.14, the midpoint will divide the line into 2. 14.14 divided by 2, we get 7.07. So 7.07, we extract a right angled triangle. With this right angled triangle, using Pythagoras theorem, so the height will be equals to 8 squared, the longest side, minus the shorter side, 7.7 squared, and this one gives us 3.744 centimeters as the height. The angle between the slant face YWV and the base UVWX. So we identify the common line, which is WV. That's the common line. Then we draw two lines, one on each plane. We draw two lines, one on each plane. The first line is here to the midpoint of UVW, and another one, it runs through the midpoint of the base. If we drop a perpendicular to the base, there's a possibility of getting a right angled triangle, and the angle we are looking for is here. So in this right angled triangle, this one is from O to the midpoint that we call the N. It is 5 centimeters because it is the base divided into 2. So we have opposite the angle and adjacent angle, we use tangent. Tan theta is equals to 3.744 over 5. Then with the inverse, we get the angle as 36.83. Roman 2 of B, we are told to find where angle between YV and the base. So identify line YV. The line YV, it is the slanting line, and the base. So the diagonal XV will make a right angle. So we look at the line VY. The common point between the plane and the line, the plane UVWX, is V. We find the projection of the line VY on the plane. So we drop this to the plane. We see a possibility of getting a right angled triangle, which is from Y to the base at the center, then to V, and then we have YV. This is our line, and this is the projection of the line YV on the plane. So the angle between the line and its projection on the plane is theta here. Then we have adjacent to the angle and hypotenuse, so we apply cosine. The cosine theta is equals to 7.07 over 8. The cos inverse of the same will give us the angle of 27.90. And our last equation in question 2, part C, calculate the angle between the planes UVY and WXY. These are the slanting faces, opposite slanting faces. So the common point is Y. Y is common for the two. So we draw two lines on each plane perpendicular to the base. So we can see that there's a possibility of getting a right angle if we drop center. So we have this isosceles triangle. We are looking for the angle. So this angle that we have there. So the angle between the two lines that we have drawn, one on each plane, to M and N. So we have MN, then Y. So we divide this one. It will divide the base into 2, because it is an isosceles triangle, into 5, 5. So if we focus on 5, which is opposite to half theta, and adjacent 3.744 is the height of the pyramid. So we can see that we have tangent of a half theta. Because of this one, a half theta, it is equals to 5 over 3.744. With tan inverse of the same, you give us 53.17 times 2 both sides. So our theta becomes 106.34 degrees. That is the end of question 2. Question 4. question 4. This a question on question 3. Complete the table below giving the values correct to decimal places. So the functions we have, y is equals to cos 2x and y is equals to sine x plus 30 degrees. So it means we double the value of x, then we find it is cosine. Using our calculators, we double the value of x and then we find it is cosine. 0 times 2, 0, cos 0 is 1. 15 times 2, 30, cos 30 is 0.87. So this is 6, 0.5, then 0. So we do the same and we get the value. The cosine of 150, negative 0.87. Cosine of 210, the cosine of 300, the cosine of 300, 0.5. Then we increase the value of x by 30 and then we find it is sine. So for example here, it will be the sine of 30 because it is 0 plus 30 according to what we are given. So after filling the table, we find the corresponding values. Then we want to determine with the table that we have, we draw a graph. By plotting, let's start with the graph y is equals to cos 2x. We plot 0, 0.5, 15, 0.87, then 45 or 30, 0.87, 45, 0, or 30, 0.5, okay, 45, 0, 60, negative 0.5, 75, negative 0.87, and 91. Do the same, then you draw a very smooth curve that is following. But remember, do not reinforce. I am reinforcing because I want you to see. If you reinforce, you are going to get double line, and the double lines are not allowed. You cannot get the mark for the smooth curve. We do the same for the second graph, which is y is equals to sine x plus 30. So we start with 0, 0.5, 0, 0.5, then 15, 0.7, 0.7, you do the same, then you plot the graph and you get the two curves. It's good that you label them to distinguish between the two. Now, using your graph, we want to find, using your grid, you find the period and the curve. Well, of the curve, y is equals to cosine. From the general form of equation of a function of trigonometric function, we know that y is equals to a cos bx plus theta, where a stands for the amplitude, b will help us, the coefficient of x will help us to find the period, and this is the phase angle. So we asked to find the period. So period is equals to 360 divided by b, which is 360 over 2, which gives us 180. Alternatively, we can go to the graph. Period is defined as the angle a wave takes to start repeating itself. We started at 1. For how long it is going to move until it also gets back to 1. So that angle from 0 to 180, it still gets back to the value of 1 on the y-axis. So then it will start now rolling back. So the amplitude will be from the maximum value of maximum displacement of the wave to where the next maximum displacement will be. That's when we say we have managed to get the curve, the period. So it's 180. Using your graph, estimate the solutions to the equations sine x plus that is equals to cosine 2x. So when the two waves functions are equated, it means y is equals to y. So we look for the point of intersection of the two waves. The point of intersection of the two waves, then we draw them. They intersect at this point here. They will also intersect at this point. So what are the values of x when they will intersect? So going with the scale we have, the one small box represents 3 degrees. So whatever you want to read must be multiple of 3's from where we are. So you cannot get anything less than that, or less than what should be a multiple of 3. So we read this one, and it gives us 15 plus something like 3 if you read it properly. So it should be 18 degrees. And this one is 135 plus 3, 138 plus 3, 141. So it also gives us another value, which is 141. So the two values of x are 141 and 18 degrees. That the cos 2x is equals to 0.5. Y is equals to cos 2x, 2x. And we are using the same to answer the equation. 0.5, it is equals to cos 2x. This is the equation we are using. If we subtract, this one gives us 0, this one gives us 1 minus 0.5. This one to this side, it gives us the equation y is equals to 0.5. So we draw the line y is equals to 0.5, and where the line will cut the curve y is equals to cos 2x, we read the values of x. So x becomes 30, and another x becomes 180. 150. These values must be exact. Why? Because if you go to the table, you'll find that at 30 the value of y is 0.5, and at 150 the value of y is still 0.5. So that is all about question 3. Question 4. In question 4, we are given the function. The function of a curve is given by y equals to a third x cubed plus 3.5x squared minus x 8x plus 4. Determine stationary points. We know that at the stationary points dy dx is equals to 0. So we need to differentiate the function. So we differentiate the function times 3, reduce the power by 1. So we get x squared plus 7x squared x minus 8 is equals to 0. We equate to 0 because the derivative must be equals to 0. So we work out for the value of x. Sum 7, product is 1, negative 8, two numbers 8 and negative 1. Substitute in the function, we factorize and we get x minus 1, x plus 8 is equals to 0. So the value of x is equals to 1, and the value of x is equals to negative 8. With this one, when the value of x is equals to 1, we substitute in the function to get the value of y, the y function. So this one gives us the value of x to be y to be negative, and this now gives us the point 1, negative 1 over 6. Then we when x is equals to negative 8, we substitute in the function of y. Then we get y is equals to 121 and a third. You can confirm. I believe that my working was well done. Then we have the 2 points when x is equals to negative 8 and when x is equals to 1. B. Determine the nature of stationary points. Here we want to determine whether the stationary points we have is maximum or it is minimum or it is a point of inflection. So we judge by having the point at the stationary point, the value of x was 1. So to the left of 1 in a number line is 0. To the right side of a number line is let me use something different. To the this is 1, to the left 0, to the right 2. So we substitute in the function dy dx, the gradient function, which is x squared plus 7x minus 8. So substitute 0, we get 0 plus 0 minus 8 minus. So the minus comes this way. Y when if at the stationary point the gradient is 0, and substitute 2, 4 plus 14 minus 8. The answer is positive. This is 18 minus 8, which is positive 10. So it goes this way. So this point now conforms to a minimum. So we have the point 1, negative 1 over 6 is minimum. We confirm another one. When we have negative 8, to the left of negative 8 in a number line is negative 9, to the right side is negative 7 in a number line. So we substitute in the function dy dx, which is equals to x squared plus 7x minus 8. We substitute negative 9, x is equals to negative 9. This one gives us 81 minus 72 minus 8 is equals to 1. So it is positive negative 8, 0. Then we substitute x is equals to negative 7. This is 49 minus 49 minus 8, negative 8. It is negative. So which point is this? This is the point which confirms. So negative 8 and 121 2 over 3 is minimum point. So the 2 points, one is minimum, another one is maximum. So this one, there was an interchange of the same, so it should be maximum. Good. Determine the equation of the tangent to the curve at 8, 0, negative 8. So we get m1, which is the gradient of the tangent when x is equals to 0. m1 will be 0 plus 0 minus 8. We are substituting the gradient function dy dx, which is x squared plus 7x minus 8. So when we have the gradient as negative 8, it is passing through this point here, which is 0, negative 8, and another point xy. So change in y minus 8 over x minus 0 is equals to negative 8. So we get, this one becomes positive, y plus 8 over x is equals to negative 8, cross multiply. So our equation becomes y is equals to negative 8x minus 8. That's the equation of the tangent. What about the equation of the normal to the curve at 0, negative 8? m1 is times m2 is equals to negative 1. That's when the normal and the tangent are perpendicular to each other. So we work out, and m2 becomes 1 over 8. The line is passing through 0, 0, negative 8, and xy. So change in y minus 8 over x minus 0 is equals to 1 over 8. So with that one, now we cross multiply 8y plus 64 equals to negative x. 64 to the other side, 8y is equals to negative x minus 64 by 8 by 8, y is equals to negative 1 over 8 x, not negative, no negative. This is x, this is x, and this is x. There's no negative in this case. So the equation of the normal is equals to y is equals to 1 over 8x minus 8, and that is the equation of the normal. This one marks the end of the revision of 4 questions. Wish you well in your studies. Bye.